Today we're going to graph polynomials from factored form. So we're going to write down what we know and then piece it together. So step by step, we're going to start with identifying the degree, the number of turning points, and potential real zeros. So when we start with degree, that's the highest exponent. Since this is in factored form, what we need to understand is that this parentheses is really multiplied by itself 3 times. So that means that we actually have an x cubed coming from this parentheses if we were going to expand it. We have an x squared from the second parentheses if we were going to expand it. And we also have an x squared from this parentheses. So we have a total degree of 3, 4, 5, 6, 7. The maximum number of turning points, we take degree, we subtract 1. So 7 minus 1 is 6. And our potential real zeros is also 7. So that's the maximum number of zeros we can have. We don't have to have 7 zeros, meaning 7 x-intercepts, but we could potentially have 7. Now let's break down each parentheses and identify what the zero is and what the multiplicity is. So from our first one, x minus 1 cubed, x minus 1 is equal to 0, so x is equal to 1. That is the x-intercept. The multiplicity is the exponent on the parentheses. So our multiplicity is 3, and if it's 3, we cross, and it's flat as we cross. Then let's go to our next parentheses, x plus 1 squared. So we set that equal to 0, and we get x is equal to negative 1. The multiplicity is 2, which is even. So if it's even, then that means we touch and bounce off that x-intercept. And the last one, x minus 2 squared, we set that equal to 0. We get 2. Then we identify the multiplicity. Since it's an even, it's going to touch and bounce. The last thing we need to think about is what our end behavior is. With end behavior, we look at the degree and the leading coefficient. So the degree is odd, so that means our end behavior is going in opposite directions, and the leading coefficient is positive. So our end behavior will go up on the right and down on the left. Now we take all of these pieces and we put together. The first thing we're going to do is plot our x-intercepts. So I changed the scale just because our x-intercepts were so close together, it was going to be challenging. So x is equal to 1, x is equal to negative 1, and x is equal to 2. The next thing I'm going to do is I'm going to sketch my end behavior. And my end behavior on the far right is going up, and on the far left it's going down. Then I'm going to go through each x-intercept and identify, am I touching, am I crossing, am I bouncing? So the first one is negative 1. So I go over and I look where x is equal to negative 1, and it looks like we have a bounce. So I'm going from left to right. I'm going to take my end behavior. I'm going to touch x is equal to negative 1, and then I'm going to bounce off and turn back. Then the next thing I'm going to do is I'm going to start approaching my next x-intercept, which is x is equal to 1. So I'm just going from left to right, and it shows me that I'm supposed to cross and I'm supposed to flatten. Now, one of the things that you need to think about is when to turn this around. So we are not finding turning points accurately when we graph these. So this graph, you might graph really, really low and turn around. That's fine. Or you might have a shallow turning point, and that's fine as well. We are not focusing on those relative maximums and minimums. So the y values don't matter. What does matter is how we cross through the x-axis. So for this one, I am crossing, and it's supposed to be somewhat flat. And so I'm just going to do my best to kind of show that it's flat going through there. So just notice that my slope is pretty flat. Then the next one I'm going to go to is x is equal to 2, and it looks like I'm going to bounce. So I just have to turn this around, and I'm going to touch x is equal to 2, and I'm going to bounce off, and then join up to my other end behavior. Now, if you don't join your end behavior, then you've probably done something wrong. So I just finished writing out the steps. We sketch the end behavior, we connect the graph from left to right, and then we make sure we join up with the end behavior again. We're going to graph another one. The difference here is we are starting in standard form. Let's first identify what our degree is. So our highest exponent is 6. That means our potential turning points or maximum turning points that we can have is n minus 1, which is 5. Our leading coefficient is 1, which is positive, and this is even. And so our end behavior, it's even, so the end behavior is going in the same direction, and because it's positive, it's going to go up on the left and the right. Now, since we're not in factored form, we need to factor. I'm going to greatest common factor, so it looks like x to the 4th is the greatest common factor. So I'm left with x squared minus 6x minus 27. Since we're solving for x-intercepts, we're going to set this equal to 0, so when y is equal to 0, and then we're going to keep factoring. Numbers that multiply together to get negative 27 and add to get negative 6. Now we're going to set each factor equal to 0. So we get x squared equals 0, so x is equal to 0. Now the multiplicity is 2, so this is a bounce. Then we get x minus 9 is equal to 0, so x is equal to 9. The multiplicity is 1, because the exponent on that parentheses is 1, so that means it's going to just pass through, or cross, or touch, whichever word you want to use. And the last one, x plus 3 is equal to 0, so x is equal to negative 3. The multiplicity is 1, so again, we're just going to cross through that x-axis. So I'm going to plot my x-intercepts, negative 3, 0, and 9. I'm going to put my end behavior on. Then from left to right, I'm going to look at each x-intercept and identify, am I passing, touching, or going through flat? So when x is equal to negative 3, we're just crossing through. Then when x is equal to 0, I'm going to bounce. So I'm going to turn around so I can touch 0, and I'm going to bounce off of it. Again, remember, the minimum spot here does not matter. We're not focusing on what the actual relative minimum is. And then the last one, at 9, we need to cross through. And by doing that, we match up with the end behavior again.